Information processing theory. After studying this chapter, you will be able to explain what is meant by the information processing view of learning. Describe the various components and processes that make up the multi-store model for or of information processing. Define metacognition and explain how it affects the learning process. Describe how technology can help students improve how much and how well they learn different subjects. In Chapter 7, Behavioral Learning Theory, Operant Conditioning, we noted that operant conditioning emphasizes the role of external factors in learning. Behavioral psychologists focus on the nature of a stimulus to which a student is exposed, the result that the student makes, the response, that the student makes, and the consequences that follow the response. They see no reason to speculate about what takes place in the student's mind before and after the response. The extensive suggestions for teaching presented in Chapter 7 serve as evidence that conclusions and principles based on analyses of external stimuli, observable responses, and observable consequences can be of considerable value to teachers. But cognitive psychologists, meaning those who study how the mind works and how the mind influences behavior, are convinced that it is possible to study non-observable behavior, such as thought processes, in a scientific manner. Some of these cognitive psychologists are especially interested in an area of study known as information processing theory, which seeks to understand how people acquire new information, how they create and store mental representations of information, how they recall it from memory, and how what they already know guides and determines what and how they will learn. Information processing theory became a popular approach to the study of learning because it provided psychologists with a framework for investigating the role of a variable that behaviorism had ignored, the nature of the learner. Instead of being viewed as relatively passive organisms that respond in fairly predictable ways to environmental stimuli, learners were now seen as highly active interpreters and manipulators of environmental stimuli. The basic principles of information processing theory were established in the 1960s and refined over the next few decades. Thus, almost 50 years ago, the stage was set for psychology to study learning from a broader and more complicated perspective, namely as an interaction between the learner and the environment. Before getting into the nuts and bolts of information processing theory, we need to repeat the same caveat that we mentioned in Chapter 1. Don't look for explanations of how people encode, store, and retrieve information from memory that can be applied to all types of people, tasks, and settings. For all its sophistication, research on memory has not progressed to the point where general laws can be formulated. The interactions between people and the settings in which they function are too numerous and complex to allow for that kind of predictability. Once again, you will have to slip into the role of teacher as artist and figure out how to apply these insights to a given group of students studying a particular part of the curriculum who will be given a particular type of test to assess what they have learned. Revealing assumptions, information, and meaning. Celeste says, poetry has always been hard for me. I can never quite hear the phrases in the same way others can, and I have never been able to memorize more than a couple of lines. It's hard for a lot of people, including my middle schoolers, says Antonio. Describing a unit his interdisciplinary team has taught, he says, we were going to read the Rime of the Ancient Mariner and then study the text to see what we could learn about the social customs of the period, geography, navigation, climate, how language evolves, and even technology. Besides being very long, it has 7 parts, the language of the poem is unusual, with changes of voice and perspective. I had the bright idea that we would learn the poem through a dramatic choral reading. So that's what we did. We practiced reciting each part in unison and then went through the whole thing 5 or 6 times. Actually, the choral reading turned out quite well. We even recorded it with transitional music, and it sounded great. The real problem was taking the next step. They couldn't apply what they had read so well to anything. They knew the poem, but they didn't have a clue what it meant. Connie says, I'm guessing that the team made some sort of adjustment that helped the students, right? Antonio nodded. Yes, it wouldn't be in the textbook if we didn't. And in the end, they surprised me with what they had learned. The information processing view of learning. Information processing theory rests on a set of assumptions of which 3 are worth noting. 3 are worth nothing. No, 3 are worth noting. Information is processed in steps or stages. The major steps typically are tending to a stimulus, recognizing it, transforming it into some type of mental representation, comparing it with information already stored in memory, assigning meaning to it, and acting on it in some fashion. At an early processing stage, human beings encode information. That is, they represent it in thought in somewhat superficial ways, as when they represent visual and auditory stimuli as true-to-life pictures and sounds, and at later stages in more meaningful ways, as when they grasp the gist of an idea or its relationship to other ideas. There are limits on how much information can be processed at each stage. Although the absolute amount of information human beings can learn appears to be limitless, it must be acquired gradually. The human information processing system is interactive. Information already stored in memory influences and is influenced by perception and attention. We see what our prior experiences direct us to see, and in turn, what we see affects what we know. Thus, according to the information processing view, learning results from an interaction between an environmental stimulus, the information that is to be learned, and a learner, the one who processes or transforms the information. What an information processing psychologist wants to know, for instance, is what goes on in a student's mind as a teacher demonstrates how to calculate the area of a triangle, or as the student reads 20 pages of a social studies text. Because contemporary information processing emphasizes the use of existing knowledge schemes to interpret new information and build new knowledge structures, it can be considered a constructivist view of learning. A careful reading of this chapter is important because the information processing decisions you make affect when you learn, how much you will learn, how well you learn, indeed whether you learn at all. A model of information processing. Information processing psychologists assume that people process new information in stages, that there are limits on how much information can be processed at each stage, and that previously learned information affects how and what people currently learn. Consequently, many psychologists think of information as being held in and transferred among 3 memory stores: a sensory register, a short-term store, and a long-term store. Each store varies as to the processes required to move information into and out of it, how much information it can hold, and for how long it can hold information. A symbolic representation of these memory stores and their associated processes appears in Figure 8.1, called a multi-store model. It is based on the work of several theorists. So, model of information processing, control processes. You have some environmental stimuli there on the left, and it registers in the senses. And you pay it attention and recognition, goes into the short-term memory. Elaborative rehearsal, organization, meaningfulness. You think about it for a while and it goes into long-term memory. And then there's some output, some response. Note that our use of the term memory stores is not meant to suggest specific locations in the brain where information is held. It is simply a metaphorical device for classifying different memory phenomena. Nevertheless, studies of neurological functioning using techniques such as positron emission tomography, PET, and functional magnetic resonance imaging, fMRI, scans suggest that different types of tasks do activate different parts of the brain. For example, verbal memory tasks are correlated with heightened activity in the thalamus. Another interesting finding is that as people become more proficient in a task, activity decreases in the cortex, suggesting that the brain becomes more efficient at processing information. But as interesting as findings such as these are, research that translates neurological functioning during learning and memory tasks into educational materials and practices is lacking, and educators should be skeptical of brain-based methods. Shortly after the introduction of multi-store models, information processing theorists divided themselves into two groups. In one camp are those who believe that a multi-store model is the best way to explain a variety of memory phenomena. In the other camp are those who favor a theoretically learner single memory system. Although this debate has yet to be firmly resolved, the multi-store model is seen as having enough validity that it can be productively used to organize and present much of what is known about how humans store, process, and retrieve information from memory. As shown in Figure 8.1, control processes govern both the manner in which information is encoded and its flow between memory stores. These processes include recognition, attention, maintenance rehearsal, elaborative rehearsal, also called elaborative encoding, and retrieval. Each control process is associated primarily with a particular memory store. The control processes are an important aspect of the information processing system for two reasons. First, they determine the quantity and quality of information that the learner stores in and retrieves from memory. Second, it is the learner who decides whether, when, and how to employ them. That the control processes are under our direct conscious control will take on added importance when we discuss educational applications a bit later. Before we get to applications, however, we need to make you more familiar with the three memory stores and the control processes specifically associated with each of them. Too often, information and meaning are assumed to be equivalent measures of student learning. We assume that if a student can remember, he or she has learned. Although it is true that students need to remember information to construct meaning, acquiring information does not lead automatically to meaningful learning. Perhaps you once memorized a piece of information, say a formula, so that you could write it in the margin the moment you were handed the test. Perhaps you even used the memorized formula to answer several test items. Do you still remember the formula? Pretty much. Even if you remember the formula, could you at this moment explain its significance? Yeah. Antonio's idea to learn the poem and then apply what was learned seems, intuitively, to be a good idea. How did he confuse information and meaning? What changes might he have made in the unit to bring about positive outcomes in the end?